Okay, Assalamualaikum and welcome back. Okay, we're going to proceed, okay, with the second part of the chapter 7. And before we move on into the phase diagram, let's have a look at several issues, okay, that we are going to address with respect to the phase diagram. Okay, so let's say we are going to combine two elements, okay, and we might want to know, okay, what is the resulting equilibrium state, okay, from the combination of the elements. Okay, in particular, let's say if we specify two things, okay, the first one is the composition of the combination. All right, let's say we have certain percentage of copper with certain percentage of nickel. Okay, and we also wanted to specify the temperature. Then, okay, we might want to ask how many phases are formed, okay, what is the composition of each phase, and what is the amount of each phase, okay, from the two combination of elements. Okay, so all of these issues, okay, are what we are going to address, okay, in the upcoming slides. Right. So as an introduction to the phase diagram, okay, let's have a look what is meant by a phase diagram. Okay, so a phase diagram is a temperature composition diagram, okay, for elements, okay, and it can be thought of as a map giving the microstructure of the resultant alloy at any given temperature and composition. Okay, so why is it important? Okay, so phase diagrams are important, okay, in engineering and science because of the strong correlation between the microstructure and the properties, okay, of the material, such as mechanical properties, okay, where the development of microstructure of an alloy is related to the characteristics of its phase diagram. Okay, so phase diagram, okay, will provide us with the knowledge of a phase composition and phase stability as a function of temperature, pressure, and composition. All right, and phase diagram is constructed, okay, from three parameters, okay, that will affect the phase structure, namely temperature, pressure, and composition. Right, and phase diagram are constructed when various combination of these parameters are plotted against one another. All right, but then as far as this chapter is concerned, okay, we are taking the phase diagram, okay, at the atmospheric pressure, okay, which is 1 atm. All right, so this is how a phase diagram looks like. Right, so we have like two different type of phase diagram, okay, on your left hand side and on your right hand side. Okay, so let's have a look, okay, at the one on your left hand side. Okay, so this is iron carbon system, okay, or it also known as iron carbide phase diagram. So this is a very important phase diagram, okay, as far as the steel industry is concerned. Right, so if we look at this particular phase diagram, okay, so the axis, okay, the y-axis is the one referring to the temperature, so it gives you the variations, okay, of temperature, okay, and the x-axis, okay, is giving you the information about the composition. Right, in this case in weight percentage. Okay, so let's not worry too much, okay, about all the details, okay, on the phase diagram, okay, but we'll come back to this later on, okay, as we advancing into the chapter. All right. Okay, now let's get a brief idea, okay, on the application of a phase diagram. Okay, so one of the versatile usage of phase diagram is to design, okay, for the design and the development of alloys, okay, because we can combine two or more elements, okay, and look at, okay, all the reactions, okay, that we can get, okay, during cooling or during heating from that particular combination of elements, okay. So it's the alloy phase diagrams, okay, are useful to metallurgists, material engineers, and material scientists for considering the following four major areas, okay. The first one is the development of new alloys for specific applications, okay. Next is for the fabrication of these alloys into useful configuration, and also to design and control of heat treatment procedures for specific alloy that will produce the required properties, okay, such as the mechanical properties, physical properties, and also chemical properties, okay. So phase diagram, okay, is very important, okay, as it can solve many problems that arise with specific alloys in their performance in commercial application, okay. Thus, okay, by using the phase diagram, okay, we can actually improve, okay, product predictability, okay, for certain particular alloys, all right. So normally the following information can be determined through phase diagram, okay. The first one is the phase present, okay. Second one is the composition of each phase, and then we can also get the fraction of weight, okay, for each phase, and also the resultant microstructure, okay. So these are the four important information, okay, that we will retrieve, okay, or obtain from a phase diagram, all right. So what data, okay, can you get from a phase diagram, okay. So it shows you phases, okay, which are present, okay, at different composition and temperature under slow cooling equilibrium conditions, okay. So it can indicate the equilibrium solid solubility of one element or compound in another, and it can also be used to indicate the temperature at which an alloy cooled under equilibrium conditions starts to solidify, and the temperature range over which solidification occurs, right, at which different alloy or phases start to melt, okay, which is the melting point, all right. And phase diagram is also used to determine the composition and amount of phases, and also the fraction of weight and the resultant microstructure, okay. So these are all that are already mentioned in the previous slides, okay. So the phases, okay, are present, okay, the composition and the amount, okay, and also the weight fraction and the microstructure and the resultant microstructure. All right, now let's have a look at the classification of phase diagram, okay. So we have three types of phase diagram. The first one is what we call as the unary phase diagram, okay. So unary phase diagram is a system containing only one pure metal, and is referred as a unary system, which can exist as solid, liquid, and or gas, okay, depending on the specific combination of the temperature and pressure, all right. So it's a one component system, okay. And the second one is the binary phase diagram, okay. So binary is actually referring to the two elements, okay. So the binary phase diagram plots the different states of matter as a function of temperature for a system at constant pressure with varying composition for two components or two elements, okay. So the addition of an alloying element represents another degree of freedom of variable, which does allow two distinct forms or phases to coexist under equilibrium condition, okay. So the mix, okay, which is the heterogeneous equilibrium phases in binary alloys also can occur in either solids or when liquid and solid phases change during the melting or solidification, okay. So it's a two component system, all right. And then we have the ternary phase diagram, okay. So ternary phase diagram is when we have more than two components exist in a system, all right. So is a three component system. Okay, the one, okay, which is very important as far as this chapter is concerned is the second one, all right, which is the binary phase diagram, okay, between two components or two elements. All right, so this is an example of unary phase diagram, okay, which is the one component system, and this is a unary phase diagram for water. All right, so we are looking at water at different phase, okay, from solid, okay, liquid, and vapor. All right, so the curves here, okay, in the unary phase diagram, they are constructed by joining the points at which two of the phases coexist in equilibrium, okay, whereas the triple join junctions here, okay, such as at the point, okay, vapor, liquid, and solid coexist in equilibrium. Okay, so in the fields of the diagram, okay, which is the phases, okay, within the phase diagram, there are only one phase axis, okay, so it's either solid, liquid, or vapor. Right, so although a diagram of this kind defines the boundary of the phase field, it does not indicate the amount of any phase present. Okay, so that's for unary phase diagram. Okay, and here, okay, we are looking at the solubility limit. Okay, so the first concept, okay, that we need to understand, okay, is the solid solution. Okay, so we are actually already look at the idea of solid solution in the previous chapters. Okay, so I guess we already look at the idea of solid solution in chapter 4, okay, during the imperfection in solids. Okay, so solid solution consists of two atoms of at least two different types. Okay, so we have the solute and we have the solvent. All right, so the solid atoms can occupy either the interstitial or the substitutional position in the solvent lattice. Okay, so the solubility limit, okay, is the maximum concentration of solid atoms that may dissolve in the solvent to form solid solution at specific temperature. Okay, so if you look at the phase diagram, okay, at the bottom right corner, okay, of the slide, okay, so the question is here, what is the solubility limit for sugar in water at 20 degrees centigrade? All right, so we know that the y-axis, okay, is referring to the temperature, and the x-axis is referring to the composition, okay, which is the weight percentage of the sugar. So at 20 degrees centigrade, so this is the 20 degrees centigrade point. Okay, so let's draw a straight line, okay, which will intercepts, okay, with the line, okay, within the phase diagram of water. Okay, that is the solubility limit. All right, now at 20 degrees centigrade, okay, we're looking for the solubility limit for sugar in water. All right, so the answer is, okay, 65 weight percent sugar. Okay, because this is the reading of the composition there at 65 weight percent. So if at 20 degrees centigrade, okay, if the composition is less, okay, than 65 weight percent sugar, so everything will be in syrup form. Okay, and at 20 degrees centigrade, if the composition is more than 65 weight percent sugar, okay, so it will be syrup plus sugar. Okay, so it's liquid plus solid here. Okay, now before we move on, all right, and look further into the phase diagram, let's have a look at the definition and some of the basic concepts, okay, related to the phase diagram. Okay,